Advanced Math kids, welcome back. Okay, let's get going. 9.4, trig functions of any angle. This is going to be from 0 to infinity, basically. And reference angles. Reference angles are basically an acute angle. Has to be between 0 and 90, or 0 to pi over 2. That measures the rotation between a terminal side and the closest x-axis. I think we talked about this a little bit. Okay, so it's an acute angle that measures the rotation between a terminal side and the closest x-axis. So if you have an angle that goes over here, so this is your rotation right there, if that's theta, this right here would be alpha. Okay, that would be your reference angle. It's always going to be positive. So if you have one that's down here, this right here is going to be your reference angle. So even though this is theta, or even this is theta, that's going to be your reference angle. And so you go around here, this is your reference angle. Theta is your standard one, alpha a lot of times is your reference angle. Okay, so that's what we'll talk about with reference angles, see that a little bit, not too much. If we were here in class, we'd hit it a little bit harder. But okay, remember sine is y. We're going to get off the unit circle, basically. We're going to get to bigger things. So if you have a vertex, you have a point on a terminal side. So xy is any point on a terminal side. Xy is any point. You have a radius. The sine is going to be the y value from that point over the radius. And that's going to be found using Pythagorean theorem. R is the square root of x squared plus y squared. Okay, so these formulas right here, these are a lot of your first questions. Pull that up here. So when they're asking you sine of theta, you need to be looking at that chart on page 1, and that's what all of these questions are coming from up through 6. X over y, you find that, see what it equals. Okay? So those are the first 6 questions, all coming from 1 there, right there. So this is questions 1 through 6. If you want to, just stop and go get those done right now. Okay. Some more terminology. Since the radius cannot be 0, there we go. The sine and cosine are defined for any real value of theta, because you can't, your radius cannot be 0, so you never divide them by 0. Okay. But your x and y can be 0, so that's why these have those stipulations right there. However, if x is 0, the tangent and secant of theta are undefined if x is 0, and if y is 0, the cotangent and cosecant are undefined. So x is 0, you have secant, tangent, secant. If y equals 0, the cotangent, cosecant are undefined. Okay, so determine the exact values of the 6 trigonometric functions of the given angle. So you have a point on your angle of -8, 15. What you need is your radius. So r equals the square root of x squared plus y squared. That's the formula from the other side. That's the square root of -8 squared plus 15 squared. Make this piece of plastic work for us. -8 squared plus 15 squared. 17. So r equals, whoa, okay, sorry. R equals 17. So sine, using our formulas from here. Okay, sine is y over r. So that'd be 15 over 17. Cosecant would be 17 over 15. Cosine is x. Remember, sine is y, cosine is x. So this would be -8 17ths. Secant would be -17/8. Tangent is y over x, and cotangent is x over y. So y over x would be negative 15/8, and this one would be negative 8/15. Okay, so you got to find your radius, and then you just use those formulas to fill that in. Okay, so here they don't give you the chart. They say let 3, -4 be a point on the terminal side of theta. Find each trigonometric function. So you have 3, -4. That is a point on a terminal side. Okay, so if you're making a right triangle with this, notice this is 3, this is your -4. 3, 4, this one has to be 5. Again, you can use this formula, 3 squared plus -4 squared, and you'll get r equals 5. Okay, so you can kind of draw your own diagram for this. 3, -4 would be down here in the fourth quadrant. Sine would be -4/5, y over r. Cosecant would be -5/4, the reciprocal. Cosine is 3/5, secant is 5/3. Tangent is y over x, so -4/3. Cotangent is x over y, so -3/4. Okay. So from that, the quadrants we've talked about, in the first quadrant, all sine, cosine, tangent are positive. So all values are positive. In the second quadrant, only sine is positive. Okay? Cosine, remember, is x. X is negative. Tangent is y over x. So if x is negative and y is positive, tangent is negative as well. So sine is positive here. Down here, tangent is positive. And over here, cosine is positive. So there's a saying that says all students take calc. Woohoo! All students, S, take tangent, calc, cosine. So all students take calc, kind of your phrase to remember the order there. So all of them in the first quadrant, sine in the second quadrant, tangent in the third quadrant, cosine in the fourth quadrant. Okay, so find the values of the 6 trigonometric functions of theta with the given constraint. So tangent is negative and sine is positive. Okay, so if tangent is negative and sine is positive, when I go back and look at here, sine is positive, tangent is negative. That's the only quadrant that we're in. Okay, so we have to be here in quadrant 2. So tangent is y over x. So when I draw my diagram, y has to be 15 and x has to be -8. Because I have to be in quadrant 2, so I have to be right there, -8/15. So from that, now you can get your radius. You know your radius is going to be 17. Sorry. Okay. So tangent of theta is y over x. So y is 15. X is going to be the -8 because we're in quadrant 2. We know that x is negative. So r is 17. Then you can find the rest of those sine values. Okay, because you have your x equals -8 and your y equals 15. So the main thing here is figuring out what quadrant you're in and which x and y values do we have here. Okay, and so then you can fill in the rest. I won't do that right now. Secant of theta is -2. So secant is a reciprocal of cosine. So that means cosine of theta is -1/2. Okay, cosine of theta is negative and sine is negative. So we have 2 negative values, and the only place that happens where sine and cosine are both negative is down here. So we're in quadrant 3 for this angle. And cosine would be -1 over r. Okay, so cosine is x over r. So x is going to be the -1, r is going to be 2. We don't know what y is. So -1, so there's -1, and we know that's 2. So if you envision, all right, paper's creeping up, a right triangle right here, your x is -1, you don't know what your y is, but you know your hypotenuse is 2. So -1 squared plus y squared has to equal 2 squared. So 1 plus y squared equals 4, this Pythagorean theorem. Y squared equals 3, so y is going to equal the square root of 3. So now you have your y, you have your x, you have your y, you have your r. You can figure out the rest of your 6 values using that chart right there. Okay. The reference angles, here's your other definition. They have to be values of trigonometric functions of angles greater than 90 can be determined from their values at corresponding acute angles called reference angles. So they use theta and they use theta prime for a reference angle. So a reference angle, they're using theta with that. That is at theta prime. And it's formed by the terminal side of theta and the horizontal axis. See you, Mr. Hoops. So this chart right here, this gives you all the formulas for that. Formulas sometimes can get confusing, but it is a nice resource in case you need to use it. If you're in quadrant 1, obviously your theta and theta prime are going to be the same one. But if you're in quadrant 2, these are the formulas you can use both in radians and in degrees. Okay, hopefully you can see that. If not, I'll get a larger picture for you. But if you always remember, okay, I want that distance from the terminal side to the closest x-axis, you can usually figure it out. But these are 3 formulas for you. So find the reference angle theta prime. So theta is 300. 300 would be in quadrant 4. So I'm going to take 360 minus 300. So theta prime would equal 60 degrees. Okay, B, theta is 2.3. This is in radians because there's no degree symbol. Okay, 2.3. Now remember, pi is 180. That's going to be about 3.14. So this is going to be in quadrant 2. So we're in quadrant. Sorry, I got to zoom out here a little bit. We're in quadrant 2 on this one. So we have to take pi minus theta, so pi minus 2.3, pi minus 2.3, oop, not pi times, pi minus 2.3, 0.841. So theta prime would be approximately 0.84. Okay, a negative 1. Theta is negative 135. So this is where the formulas sometimes break down. Okay, so if you're at 135, you're going to be in the 3rd quadrant. So if this is negative 135, you need to know what is this right here. Okay, so in this case, you want to take 180 minus 135. And you get 45 degrees. So here, theta prime would be 45 degrees. And what they're saying with these reference angles is like the tangent of negative 135 would equal the tangent of 45 degrees. Okay, the sine of negative 135 would equal the opposite of the sine of 45 because sine is negative in the 3rd quadrant. So you can use that to find some other bigger ones, but basically finding it gets you experienced with it. To see how a reference angle is used to evaluate function, consider the point xy. This one, that's just going to confuse you. We're moving on. Okay, I think we're actually about done for what you'll actually have. Okay, I think the last stuff you have is just use a calculator to configure these and make sure you're in the correct mode. So this one you want to be in radians. This one you're going to be in degrees. And this one we want to be in radians. So I'm currently in degrees, so I'll do this one first. So you probably won't notice it once I piece these videos together. We had an issue there at the end. But here are the final answers that I got on this last page, how I typed them in the calculator. So that about wraps it up for this one. I hope you're doing well. Stay Bluebird strong. We'll talk to you later.